All right. Hello, everybody. Welcome back. Figured I have a couple of minutes here to stream, so I'd hop on while we discuss some of the concepts for the small business manager here. All right, let's let some people roll on in. Hey, Mahan, welcome back in. How you doing, dude? I'm good. We did a earlier stream today. This is gonna be part two. This one won't be too long. I did a 3 hour stream earlier today, so you can reference back and watch that one if you would like some more content after this stream. But I'm gonna go see a movie tonight with my lady, so we're gonna bow out here after I'm just while she's cooking dinner for herself and doing that. I figure I'd hop on and try to get some work done here. So if you guys have been keeping up in the Discord, we've been discussing some issues that we've been having and the inevitable truth or uh, inevitable path that we were going to have to go down anyways is kind of here now. So I've realized that I've kind of been doing things slightly incorrect. Um, Whereas I'm not supposed to be treating items as expenses, which I am right now. They're supposed to be counted on a balance sheet for assets. So we currently need to restructure. And honestly, I think at this point, this working attempt that we have so far is kind of scrapped, like, in all honesty, which is kind of a bummer. I've written over, you know, 1,500 lines of code in this one file alone, which is quite a lot. I have a lot of thinking and hours gone into this project, and it's kind of upsetting that we're having to now move on to a new iteration of it. But at the end of the day, I guess it's just about the learning process, so that's what's important. Let's go ahead and fix the chat here. Okay, there we go. All right. So let's go ahead and I'm gonna create a new repo, I guess. Right, it's kind of how it is now. So here, new folder, small. Business. All right, and then we'll. Okay, let's go here. Open folder. Um. All right. All right. Okay. Do you think student loans worth it anyhow? What do you mean? I'm not sure. What are you referring in terms of like school? Hey, Tim. All right, so we are starting the project from scratch here. So if you guys, this is the opportunity here to suggest things. We have the opportunity to really um, get some structure going here. So I'm going to just start it off by adding some simple classes and then um, and then go from there, right? So I think we've been suggested to use Fast API for doing API requests. We're gonna have to think of what framework we want to use for the front end, whether we use React or we try to just use raw HTML, CSS, and JavaScript. I'm not sure, so we'll have to really think of it and go from here. There's a lot of things to cover here. We are starting the small business manager over. We are going to just bite the bullet and say, we need the working 2.0 version will be, um, you know, better suited for our needs as the 1.0 just really was becoming more and more difficult to use. So if you guys still want the 1.0, I can put that on GitHub, and although it's not really completed and resolved, I could put that up for you guys to just reference and look at. But I think that we're gonna go ahead and move on. Unfortunately, we just weren't structuring it appropriately for how we wanted to structure and for modern day accounting purposes, and we needed to kind of start over. Unfortunately, it sucks, but okay. So we're gonna do item. Okay, we have classes. Item class dot py. Okay. So okay, so obviously, so we're gonna have, obviously a class item. We're going to have a def the initialization. So we have the initialization. We want to provide what parameters? Okay, so we have an item. The item has an ID, it has an ID, it has a name, it has a cost, it has a date, or a purchase, a purchase date. It has cost, a purchase date. What other things should we suggest, you guys? Suggest some stuff that we should house for item containers. Right, so let me pull up on my other screen here, my Sheets database for my current small business and reference what I currently have tracking on there. Here we go. So number, date purchased. Okay, let's do this. ID, date, purchased. 'Cause 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 do this. ID, date, p item number. I kind of want to keep this as item number, right? Item number, date purchased, date listed, date sold, right? Those are the date attributes needed. Then we need a description. So item description. We have a item size. We also are going to have a item description, item size, so I'm not sure if I want to have all these be required. Amount sold. Yeah. So item number, date purchased, date listed. So hold on, we're going to do date purchased, item description, item size, item size. So those are all the required attributes to make an item right up front, to load an item into the database. Okay. So a number. It's a lot of information to keep track of here. A number, a date purchased, a description, a size, and a cost. Item cost, right? So these are the required attributes. So required attributes. Self dot item number is equal to item number. All right, we'll duplicate this down and let's go here. Date purchased. Item description. Oop. Item size. Item cost. To make an item, right? Then you have non-required attributes to make an item, right? So now we're going to initialize self dot what are we going to put here? That's a good idea, AJ. Thanks for reminding me. We'll start. Okay, so item number. This is going to be an int. Date purchased. Going to be a stir. Description. It's going to be a stir. Item size. It's going to be a stir. Item cost is going to be an int, right? Perfect. All right, how's that look, AJ Brady? Okay, so then the non-required attributes. So you need these five to just load an item into the system. But you have other date attributes that aren't required, right? So we're going to say self dot date list or listing price equals none, right? Self dot date listed is equal to none. Self dot sold price item size date listed sold price is equal to none. Self dot date sold is also equal to none. And then okay, and then we have and then a status. So say default to none. And then this is non-required attributes. Make an item default to value to bool maybe, and do self dot status is equal to quote in storage listed sold. Python LSP, is that an extension? Python extension pack. LSP. Ruby LSP. Which one is it? Python. What's this? Python indent, auto docstring. Jinja. Hey, Wing On! Welcome back in. Okay. So attribute to make an item. So what other attributes do we need? So we need self dot sale method is equal to none. Self dot transport method is equal to none. Sold price, shipping, handling charge. Sale method. That'd be more on the transactions sheet. Okay. Item class. Status equals, quote, available. Okay. Available. Unavailable. So it's going to be unavailable at first. Or say status is in storage or in inventory. Inventory available. Inventory unavailable, right? So that's the status. Okay, so now these are some basic attributes that we're going to keep track of for this item, right? We'll have another class called transaction where we'll transact the item, and then we'll record some more information from there. So inventory unavailable, because this is just the raw characteristics pertaining to the individual item. So the number, which is a unique item number, right? Number for every item, right? We have a date, purchase date, the item was purchased. This is description, a short description of the item, slash name of the item, the size, right? And then here is the cost, the good, right? So item, cost of the item, cost of good. Okay, right? This is just the date the item was listed. This is the date the item was listed. This is the price the item was listed for. Price the item was listed for. This is the price the item was sold for. This is the price the item, or the date the item was listed. The item was sold on. right? And so this is just the status of the item, um, simply put like that. Hey, Colby's Frog. You're definitely on the right track with the transaction table. I would throw the none defaults on a listing class slash table. Okay, so you want me to say like class um, for sale item, which takes in an item. We def init right. We do the init on self. So if I super, how do I inherit the parent attributes? When you super allows you to super init the name from the child, age. Okay. Okay. So we'll inherit all of these from the um, from the uh, from the item parent, and then we'll put. I like that idea, Colby. Let's put the listing price and the date listed here, right? And then we'll, what did I do? It's init super. Super on the init, the name, the variables, okay. Super under init. Really? Is it lowercase super? Yeah. Init the item number, date, purchased, item description, item size, and item cost, right? And then we set self dot, and then we'll just copy this here. Equals listing price, and then this is date listed, right? Okay, so we'll need, so then we'll say here, inherited attributes to make from item, except I don't want to inherit the status, right? So I'm not inheriting status we're going to remove this one, right? Mahan's liking the project so far. Nice. Okay, so now we inherit attributes from item, inventory, status equals, quote, inventory dash unavailable, right? So that's where we inherit from, right above. And then we're going to set now the self.status of this item now is going to be this is going to be inventory available for sale, right? How does that look? So if I go to convert an item, I have to provide it some of these additional attributes of listing price and date listed. And then it'll be a for sale item. But does the original item object become obsolete? In styling, you should have most 5 to 7 params, but you can make it simpler. Line 23. Oh, gotcha. So we have 1, 2, 3, 4, 5, 6, 7. So we maxed out here. Okay. So then we override the status of this guy, right? Because we're not inheriting a status here. So now we need to make a class called sold item. It takes in a for sale item. And we'll say, we'll initialize this guy. So do I have to just keep pulling all of these attributes down? You know, like that. And then take this down there. Do date listed, date sold price is an int, date sold stir. Okay. To sold price, date listed, or sorry, date sold. Okay. We need to do super dot init all of these including listing price and date listed. to make a for sale item. Right? And then these are the required attributes to make a sold item. Okay, so if you make a sell, well, actually, do I need to inherit all of this stuff? Do I need to inherit all this stuff? Like, because I just need to inherit the item number, right? I don't need to inherit like duplicate data, like, right? The only thing I need is the item number across each parameter. Like, the for sale item doesn't need to know the date purchased or the description. Well, maybe it needs to know the description, but like you can just you can reference the item with that same item number, right? Hmm. So I'm gonna take this. I'm gonna go here. I'm gonna say I am making some classes for items for sale items and sold items, and I am curious if I really need to inherit duplicate data when duplicate data don't show any code. What are your opinions? In your design, inheriting like item number, date purchase, item description, and size in both for sale and sold can feel redundant since these attributes are shared across all items. Instead of duplicating this information, you consider a couple of options. Use composition over inheritance. You could create a base item class with all the shared attributes and then have for sale item and sold item contain an instance of item. This way, you're not inheriting the same attributes, but rather composing them within a specified item type. This is a cleaner approach when multiple classes share common attributes but represent different states of an entity. Refactor to use fewer classes. Another approach would be consolidate logic into fewer classes, changing the item instead of creating new classes for different states. Okay, so if I want to go with the first approach, would I pass in item? Yes, if you go with the first approach using composition where you have an item instance inside for sale and sold item, you would pass it in an item instance when creating those subclasses. Each for sale item and sold item would have an item object as an attribute, and you would interact with it across those and you would interact with it to access the shared attributes. Here's a rough breakdown. The for sale item and sold item classes would take an item as an argument in their constructor. Okay. So instead of supering all of the data from the item, right, and have the item the for sale would not inherit an item. Wait. Would it still inherit the item? No, if use composition, you would not be inheriting the item, so you'd include the instance. Item object. Okay, so we would say rather that our class for sale item would take in its initialization a item of type item, and then a listing price, and which is a int, and then a date listed, which is a str. Right, and then self.item is equal to item provide. Why don't you make an attribute quote kind or quote status and make it sold or for sale? Make it available and then gets true or false. Nah, honestly, just having fun. That's what I did last time. Is I stored it all under one item. So I figured that this is just more Pythonic because that would just mean I'd have one item class with a mass amount of attributes. So for sale item takes in the item, and then you do this here. Right? Override the status. So then we're going to say self.item.status is equal to quote inventory quote for sale. Right? So we're passing in the item. We're setting the items.status to for sale, and then giving it two more attributes here. What was that? I do not wear contacts, no. So I would take care of that. Then in sold, we have, I'm not going to inherit this. We're going to go on the initialization. We're going to inherit a date sold and a sold price, but we're going to inherit an item before sale item. Right, so this is the type for sale item, and this is of type item. we're going to remove this. We're going to do um, uh, inventory. I'll make this inventory available. And then, so sold price, item for sale, we set item equals to, self.item equal to item self.item.status is equal to quote sold item. Just sold. I'll just say inventory for sale and sold. Okay, and then self dot for sale item equals to for sale item. There. Cool. So now let's take that and see if it likes that a little bit more. Okay, I made some changes. How do these look? Don't show any code. The changes you made look good in terms of moving towards composition and separating the concerns between item, for sale item, and sold item. Here's a breakdown of your structure looks. Item contains the basic attributes and initial status. This class is simple and well defined, which is great and reusable for data storage. For sale item, instead of inheriting from item, it contains an instance of the item. The status is updated to for sale, and you add the listing price and listing data as additional attributes, which makes sense. Sold item similarly takes the item and a for sale item, and the status is updated to sold, and you track the sold price and date sold. This is a good way to track the history of the item's life cycle. Overall, this structure improves separation of concerns and avoids redundancy. By using composition, you're making the data flow cleaner and more flexible. You're also keeping each class focused on a specific aspect. Item holds general data, for sale item handles listing info, and sold item tracks the sale data. A couple of things to keep in mind. You don't need to pass item again in sold item class since you already have it in for sale item. It might be redundant to pass it twice, but it depends on your exact use case. Okay. Ensure that you update the status in each subclass you handle. Ensure that when you update the status in each class, you handle potential edge cases where an item might be reused in multiple contexts. Okay, so then we don't need to pass in an item. So you say for sale self dot for sale item dot item dot status equals sold, like so. Right. Okay, so I changed the sold item to no longer include the item from for sale. Your updates look well and thought out. By removing the redundant item attribute from sold item, you're streamlining the design, making it more focused and avoiding unnecessary duplication of data. Here's a quick summary of your structure. The core class holds the essentials. Sold item, now instead of holding an item, it takes a for sale item which already contains the associated item. When an item is sold, you update its status to sold via the for sale item. benefits of this design. If you're planning to extend this further, you might want to consider adding methods that can update the status of an item in a controlled way, like a method to change from inventory to for sale and then to sold to avoid direct manipulation of the status outside of these classes. Hey, Owen Wu. Appreciate you for joining me here. Thanks so much for coming in. Do you study system design? No, this is, I guess, our study of system design. We're doing it now, I guess, live. We're doing it live. Thanks for coming in here. Appreciate you. What you guys working on? What are you guys studying tonight? Share with me some information. How are you guys doing? I'll be right back. Let me get some juice. All right. Sweet. Um, we'll do it live. Yes, exactly, Tim. Pretty much done with the allocator. Nice. That's awesome, AJ. A lot of hard work today, sounds like. Okay, so do you guys see anything that we want to add into here? Do you guys see anything that we want to add into here? Owen says, I guess my question is, if the goal is to land a software engineer job, wouldn't it be more efficient to study interviews versus doing projects? I don't know. Does anybody have any input on that for software engineers? Or I'm not sure. I'm a chemist. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist. I have a full-time job, 9 to 5, Monday through Friday, as a formulation chemist. And I am just coding and working on projects for fun, basically, to gain new skills. So whatever happens, happens. Whatever doors open, they open, and we'll see what happens from there. Thanks for coming in, Owen. Okay. All right, so now what's next? May as well get the resume ready and apply after managers get back from March Madness vacations. Tim wants me to start applying for jobs. Projects are to get your resume looked at. Leak coders for passing the interview. Tim's want me to start putting myself out there, huh? Okay, so um so actually that goes there because it's all required. And then this is to set item status sold, right? And so then we'll go here like this, grab this, that there, paste, move this, and X, delete this. And then we'll put this set item status for sale. Cool. So now we need to have so it said it wanted me to make maybe a method. If you're planning to extend this, you might want to consider adding methods that can change, update the status in a controlled way. So update, this will be set item status to inventory. Okay. Now what? Now we have the item, the for sale item, and the sold item. We have all of these being accounted for. Now, do we want any methods to do these? Um, hmm. Where to go from here is the next question. Right, so because there is no inheritance, I can't have methods apply to all the classes. Methods won't automatically be shared, which is typical strategy one and benefits when using inheritance. However, there are a few strategies you can still apply with common functionality. Here are a few approaches. Common methods to use. You can define both shared methods in the item class and then simply call those methods from the other classes, since both contain instances of those. Okay, so then don't show code. You can define methods. Another option is to use mixins, which are classes that provide specific functionality like shared methods to other classes. You can then include the mixin in multiple classes to give you access to shared methods, helper functions. If you'd rather not modify the classes, you can create helper functions outside that perform common actions like updating the status. These functions would operate on instances of your classes, allowing you to reuse the logic across different parts of your program. So okay. Now, hmm. Well, where do we go from here? Now what? That's the question. Um, we have a item class that houses all this information. Do we want to house so the sold item is also going to have a um, net profit, item net profit, right? Because um, so we'll pass in here non required attributes to make an item. Right, so this will be self dot um, uh, hmm, self dot uh, net profit. equals none. Okay, and then we'll go here. So these are required. And then we'll have a non-required. Make a sold item. And this is going to be self dot for sale item dot item dot net profit equals to self dot sold price subtract self dot or self dot for sale item dot cost item cost. Right? Hey Don, so welcome. We are restructuring and restarting our project here. It's a big ask here, but we are working on the more structured, more streamlined version. Right? So we give net profit is equal to self.sold price minus self.for sale item cost. So I'm going to take this, I'm going to see if it likes that. Let's go. Okay, your approach to the item, for sale item, and sold item classes looks solid overall. You've separated different states an item can be in inventory, for sale, and sold, which is a good design choice for clarity. Let's break it down. Item class, attributes. You define the essential attributes like item number, date purchased, item description, item size, and item cost. These are fundamental for tracking the item itself. Status, you've properly initialized the status as inventory, which will later be updated when the item is listed for sale or sold. This is a key part of our design. Net profit. You've included a net profit here, but it's set to none initially. Consider whether you want this to be a calculated value as you are doing later in sold item, or if it should be directly tied to sales transactions. That's a good point too. Type annotations. If you're using type annotations, which is great for clarity and safety. Cost attribute. In the current design, the item cost is an integer. If you expect fractional values, prices like this, you might want to use floats for price attributes like item cost and sold price. Method for updating status. Instead of directly setting status in other classes, you could consider adding a method in the item class to handle status updates. This would centralize status management and make it easier to modify. Instead of adding, you could use a method in the item class. You're calculating net profit in sold item, which is good approach for tracking the profit. This value depends on the item cost and the sold price. However, you might want to consider whether net profit should be updated in the item class when the item is marked as sold rather than in the item class. Sold item class. This would keep responsibility tracking profit in the item itself. Calculation of net profit. The current method calculates in the item is sold. If you want to make sure the calculation happens only once and only when necessary, you might want to add a check to ensure that the profit is not recalculated multiple times. You're encapsulating related data well. mark as for sale, mark as sold in the item class. Okay, so we'll go here, def mark for sale is going to take in self, right? It's just going to say self dot status is equal to quote for sale. Okay, we're going to do def mark sold on self. We're going to do self dot status equals to quote sold. Okay, this is going to do item dot mark self dot item dot mark sold, mark for sale. Item dot self dot item dot mark sold, mark for sale, and then sell, right? So then I'll say if I add a mark sold and mark for sale in the item class, how can I call those functions in the for sale item and sold item classes? If you add, since both item and held item, you reference that mark for sale. Once the item is listed for sale, you would mark the call of the item instance. Okay. Mark for sale on self.item. And then here you would do self.mark sold. Self.item. For sale item dot mark sold, like so. Your structure looks almost there, however, there's a small issue with how the methods mark and are defined in the item class. These methods need to be the same indentation level as the init. Oh, that's so okay. That's why they weren't showing up. There we go. Now they're there. You don't need to call self.item.mark for sale and self.item.mark sold and then assign them to self. Okay, so it's not returning anything. So we can just call the function like so. Yeah. And so then let's remove, I don't want to track net profit here. Like, I don't want to do it. Cool. All right. Nice. Tracking net profit. I got rid of net profit. sold item hmm. I'm not sure. Usually I put them there. So does it not like this? I removed net profit. Right now there's no validation for status changes. Like, you may want to add logic that prevents an item from being sold twice or listed. Okay. So if self dot status in quote for sale and sold raise attribute error. What's this? Should I raise an attribute error? No. Value error. Say as E. No. Raise value error. And then as item is already for sale. Error. Item is already for sale. Okay, and then the same here. If self.status equals to for sale, right, raise out value or elif self.status equals to quote sold we're gonna raise value error quote error item is already sold, else self.status is for sale. If self.status equals to quote inventory raise value error error item is not listed for sale, right? If else, if it's sold or is already sold. Then set status to sold if not. Okay, how about that? So if you do print error and return or break, is the behavior the same as the raise? So if you do print error and return or break, is the behavior the same as the raise value error? The raise value error will like actually like stop the program like deliberately if they like, and then so I'll have to add in catching of these value errors upon conversion of these basically manually. I think. Anybody else got a better explanation than that? Your update code looks solid. The added validation checks for mark for sale and mark sold methods are good improvement, ensuring that you cannot transition an item into an invalid state. Marking an item as for sale if it's already sold. Here's a quick summary of the changes. The validation logic. The mark for sale and mark sold methods now raise appropriate exceptions when trying to transition an item into an invalid state. This helps prevent errors that would arise from improper transitions. Error handling. You effectively incorporated value error to handle erroneous transitions, which is good practice when dealing with state changes in objects. For sale and sold item classes. The interaction with item class is now smooth, where for sale item class calls mark for sale, and the item object in sold item class is called mark sold on the for sale object. This keeps the state consistent between the different stages in life cycle. Suggestions for improvement. Switches for the future. Profit calculation. In the sold item class, you may want to calculate the net profit when the item is sold. This can be done directly in the sold item constructor between the sold price and the item cost and storing any net profit in the item class. Database. As you proceed with storing these objects in a database, consider how you'll map these classes to database values. Using an ORM like SQL Alchemy would make this process smoother and provide automatic handling of these relationships. Item to item for sale to for sale sold. Future enhancement. If you plan to extend this into future tracking inventory handling expenses, you can start building out a business manager class to interact with these entities, as we discussed earlier. Exactly. This class can centralize the business logic and reporting functionalities. Sweet. Yeah, Colby, a few people have suggested, pair programming. I'm definitely interested, so shoot me a message on Discord. If any of you guys are interested in doing some pair programming, I've been wanting to open up the stream to be more interactive for the viewers and to, if we want to do like an hour, say an hour and a half segment every once in a while where I, have a kind of like a guardian angel programmer above me watching what I do and, talking me through things, then I think that would be really cool. Yeah, for sure. What kind of stuff does that entail, Colby? Like, what is it? What would it require? Hey, Gina, what's our movie? We gotta leave at like 6:30. Okay, I'll wrap it up here soon. No worries. All right, cool. So we have an item class now, and so, right, we're gonna need to make a business manager class. Right, it said to interact with these entities as we discussed earlier. So let's talk about database integration. I am pretty novice and will need some guidance on what it is and how to do it. I have used SQLite 3 in the past. Database integration essentially means connecting your Python code to a database, in your case SQLite, to store and retrieve data. It helps you persist information beyond just running the program, making it easier to handle large amounts of data, keep track of your records, and ensure data is maintained even if the program is closed or restarted. Overview of database integration. Here's a high-level overview. What you'll need, what needs to happen. Connect to the database. Using a SQLite library, SQLite 3 in Python, to open a connection to your SQLite database file. Define tables. You need to design the structure of your database by creating tables that will hold your data. Items, for sale items, sold items, expenses. Add records to your database when you create instances of your classes like item, for sale item, etc. Add records to your databases when creating instances of your classes like item, for sale item, etc. Retrieve information from your database to load and display data as needed in your application. How to do it with SQLite in Python. SQLite is a lightweight serverless database, and SQLite 3 is a standard library in Python to interact with SQLite databases. Since you're familiar with SQLite 3, we can go through how to use it to implement your database structure in your project. Install SQLite. If you're not already available, install SQLite. Since SQLite is built into Python, no extra installation is needed. You can import SQL 3 directly. Connecting to the database. To connect to a database, use the SQLite3.connect method. If the database doesn't exist, SQLite will automatically create it. You need to define the table that matches the structure of your classes. Here's a basic example of the table item, of the item table. Inserting data. When you create an item or other objects, you'll insert the data into the corresponding database tables. For example, item equals the creation of an item with item number 1, a date, t-shirt, large, and a price. Cursor.execute. Oh, so cursor is just the name of our database. Con equals this. Con.cursor. Cursor. Oh, okay. Do you guys have any suggestions if you're watching for, what we should do database wise? I really want to make this interactive, so please, we're starting our project pretty much over from scratch, right? We've been working on the small business manager for weeks to months now, and we're having to kind of start over from scratch to really make it more of a streamlined process and just more fluid. We had over 1,500 lines of code here that we had written, a lot of a lot of interactions, a lot of work, but we are kind of starting things over here, and let me know what you guys think. So we mark for sale, mark sold, right? For sale item, sold item. So what do you guys think? Postgres would probably sound better on a resume than SQLite 3. Add UI, and I'm happy. Well, we're gonna get there, Mahan, for sure. We gotta add UI, definitely. That's honestly the part I'm avoiding because that's the part I have least experience in. Okay. What kind of database would you suggest I use? I you mentioned SQL/alchemy, but I don't know what that is. What about Postgres? What are the pros and cons, and what would work well with this project? Okay. For your project, PostgreSQL, Postgre. What is Postgre? What is that? Could be a great option, especially if you plan to scale up in the future, need more advanced features, or expect your database to grow significantly. PostgreSQL Pro scalability. If you can handle large amounts of data and more complex queries than SQLite, making it ideal for growing applications. Advanced features support things like full text search, JSON B data types, and advanced indexing, which can help you build more complex features in the future. Data integrity and reliability, ACID complete atomicity, consistency, isolation, and durability, meaning it ensures reliable transactions. Concurrency supports multiple concurrent users and transactions without much performance degradation. Industry standard is widely used in product systems. Cons: setup complexity. You need to install and configure a server, though you can also use and manage PostgreSQL hosting like Heroku and AWS RDS. Overhead: for small projects or prototyping, it might be overkill to set up and resources it requires. Okay, so this is really like more advanced stuff. Like you have to set up with a server and everything, like AWS. SQLite, you've used it before. Pro, simple setup. It's file based, lightweight, low overhead. It uses less system resources compared to a full fledged database. Portable. Limited scalability, limited advanced features, not suitable for heavy concurrencies. SQLite Alchemy. SQLite Alchemy is a Python or ORM, object relational mapper, that allows you to interact with the databases using Python classes. Instead of writing raw SQL queries, you define models, classes, and SQL Alchemy automatically handles the conversion between Python object and database rows. Allows you to focus on Python code rather than raw SQL queries, and you can make the code more maintainable and portable. Oh boy. For a small business project, if you're planning to stick with a smaller, more contained system with moderate data requirements, SQLite is fine to get started. But if you foresee growth in complex query or high traffic, PostgreSQL will be better for long-term choice. SQL Alchemy would make your life easier when dealing with these databases, as it abstracts the SQL and helps you manage your models and databases interactions in Python. Oh boy. Oh boy. Um, I wouldn't worry about what database to use. SQLite is perfect for this in use case. It's okay, Owen. I appreciate your feedback, dude. Thank you so much. It was good to dive into these. SQLite is used for app data, and Postgres are like providing data for apps. I sent a little diagram of the database to your DC lols. To your DC? Oh, my Discord? Okay. Item, ID, name, cost, sale price, status, purchase date, sales. Gotcha, yeah. Is there an app for this type of thing? So we just need to incorporate in between item and sold item is for sale item, right? That looks really good, Don. So look at us collaborate. We're collaborating on this. All right, we're almost to 100 viewers on for the stream for today. So thanks so much for being here and joining me. Oh, my phone just updated to the new software. Okay. Don't remember doing that. So we agree SQLite here. AJ, when it comes to database, you always argue about SQLite. Other people's just it's all right. We like no having different suggestions and different angles is really good. Even if some people think SQLite's better, if some people think um, SQL Alchemy or PostgreSQL is better, then vice versa. It's great to get all sorts of inputs, and we can learn from everybody's opinions. It's really awesome. I appreciate everybody's feedback here. Um, so if we do SQLite though, right? They have to. Will that download a database file to the user's storage device, right? Like use TXT. Don Soap trolling. Don Soap just fully given up. Is he trolling now? All right, hey Sand Programming, thanks for coming in. I appreciate you for joining me and following along. How are you doing? Welcome. Thanks for commenting. Store it in your brain. Okay, so um, so let's just stick with SQLite for now, right? Um, so I would have to, what I need to do is set up all of my classes, right, for my item, my business, my balance sheet, my income statement, and then I need to link those all into the database, correct? That is a lot of work. Oh my goodness. So let's go over the classes I had outlined and get ready to create them besides item and sync them with a SQLite DB. Great, let's break down the classes you outlined aside from the item and prepare them in the SQLite. Let's plan. Okay, so the for sale item class, foreign key to item, listing price date listed, database table, sold item. There's a lot of work to do. Um, if this project gets serious and you like really start investing in this and having this go actually professional and service other people can then use, then a real DBs would be better. If you plan on being an app people can install locally and their data is stored on their device, SQLite is perfect for that use case. Well, I'm kind of torn. Should we have it be a web app or should we have it be a desktop app? I don't know. I'm not sure. Maybe we should just stick to desktop app for now, but that would require us to use like to Kinter and stuff. I thought we were going to try to use, HTML or maybe even React or try to learn React or something like that. But anyways, you guys, I'm running out of time here. I'm going to go see a movie with my lady friend. We're going to go see a movie tonight. I highly suggest you guys get out, stretch your legs, grab some food, relax. I potentially maybe after the movie will jump back on after my lady falls asleep for a late night after hours coding session with some tunes in the background or something. But please, you guys, as we're starting this project, we're starting this project over again. So this is our opportunity to really work together here. And so if you have ideas, suggestions, or implementations, please join the Discord, chat with me in the general chat, and then we can make it, you know. We can really incorporate everybody's ideas together into creating this project all as one. And then once I get like not a working but like a stable structure going with the database and everything, we can push it to GitHub, and then we can submit and take pull requests from the viewers on the chat, and we can work on it side by side with everybody. How does that sound? Uh-huh. Yeah, I'm honestly not sure like about .exe versus what, like, you know, what do you guys think? Just keep it as a pie file with like a module or a library for graphic interface. Anyways, please join the Discord link down below and chat with me in general chat. I'll be in there over the course of the evening and we can talk about more features to add because the more we talk about and discuss, the quicker we can implement stuff in on the stream here. So please think of stuff that we can add, suggest things. People have been talking about all sorts of great features in there. And so today we implemented the item class, which has a marked for sale and marked sold, has these various attributes. We have a for sale item, which this it doesn't inherit, but it takes in a condense. What's it called? Compressioning or something? What's it called? Um, what's it called? Composition. Class compositions. So where we use composition over inheritance. So this is composition where we have a class basically received as an attribute, and then we can access the various methods within that received attribute, right? Um, all right, guys, I'll see you later. I'll talk to you later. Please join me in the Discord and talk to me there for features, and we can think about our next steps moving forward. Honestly, I am really kind of lost here about where to continue. Normally, at this point in time, I would be working in the Python terminal, creating text menus to prompt the user to add and start loading in these classes with information and start generating items and then saving those into a CSV or a JSON file. But we're not doing that anymore unless you guys want me to try to implement that first and do my old way and then do it with the database. But I think now is the perfect time to just take the band-aid off and just try something new and learn something more beyond our current ability.